Hi there, this is Mrs. Often, and I'm happy to have this opportunity to talk to you about rotations in the coordinate plane, part 1. This video will focus around rotations around the origin, both in a clockwise and counterclockwise direction, given angle measures of 90, 270, or 180 degrees. So by the end of this slide deck and video, you will be able to rotate a polygon about the origin 90 degrees clockwise, which is the same as 270 degrees counterclockwise, 180 degrees clockwise or counterclockwise, or 270 degrees clockwise, also 90 degrees counterclockwise. It's important to recall that we can perform this with rules or visually. We're going to take the visual approach to develop the rules. So if you forget the rules, the visuals will help you. Here is a rotation about the origin that's performed 90 degrees clockwise or 270 degrees counterclockwise. So just keep in mind, clockwise goes like this, and counterclockwise goes in the other direction. We know this is 90 degrees because when I connect the center of rotation with the vertices of my rotated figure, I can see that I have a right angle here as determined by the slopes of the lines. I'll notice that for my motion of my point B to B prime right here, my point B has moved from -1, 2 to 2, 1. Looks like the points have flipped, and that second coordinate, that y coordinate, has changed in value. Let's see if the same thing happens at point A. Point A is starting out at 3, 2, and it rotates around here to 2, -3. So that's my location for A prime in the image figure. That tells us our rules for transformation are that the coordinates are going to switch positions. X becomes y and y becomes x, and the new y coordinate is changed to the opposite value. So x, y turns into y, the opposite of x. Let's see what happens in a 180-degree rotation. Here's our triangle ABQ, and we'll notice that passing through the center of rotation, I can draw a straight line segment from B to B prime, from A to A prime, and from Q to Q prime. I notice that Q changes from 0, 10 to 0, -10. I notice that B, in moving to B prime, changes from 1, 2 to -1, -2, and A moves from 4, 2 to -4, -2. So this is pretty easy. Fortunately, with 180 degrees, clockwise or counterclockwise doesn't really matter. They'll both end up at the same spot, and it's a super easy transformation. Both coordinates will change to their opposite values. X, y will change to opposite of x, opposite of y. Our last rotation in the coordinate plane is 270 degrees clockwise, which is equivalent to 90 degrees counterclockwise. So drawing once again that right angle between my two coordinates here. There's another one from A to the center of rotation over to A prime. I won't draw Q because it will pass over B. I notice that my point B has changed from 1, 2 to -2, 1. A has changed from 3, 2 to over here at A prime, it is -2, 3. So this is similar to what was happening in the 90 degrees clockwise, 270 degrees counterclockwise rotation, where I was flipping the order of the coordinates and one was changing to the opposite. However, in this case, it is changing in the new x coordinate position. So I'm flipping that order, and then my new x coordinate is changing to its opposite. Let's see what this looks like when notated symbolically. So my rules for transformation, the coordinates switch position, and the new x coordinate is changed to the opposite, so xy becomes opposite of y, comma, x. I hope you found this to be useful. Again, I have an exploration on Desmos for this if you would like to explore more about these rules for transformation. Thanks, and have a great day.